Hi, my name is Alexandra Mayhoya and I'm from EC41. This is laboratory activity number 6 for robotics laboratory subject. It is entitled Accelerometer. Today is November 30, 2021, and my instructor or professor is Engineer Jacqueline Carduque. So to start off with our experiment, the objectives of this experiment will enable the student to control the angular displacement of the robotic arm using the accelerometer. Next is to create a program user interface to display data coming from Arduino. So the second objective here, we are not to do this since we are not asked to make a computer program user interface. Next, equipments and materials. Let me just go back to the objectives. It says here that we are to control the robotic arm. Instead of a robotic arm, we used 3 servo motors. So let's take note of that. So moving on, equipments and materials, we are going to need the following: a personal computer, one Arduino microcontroller, one servo motor. Next, we're going to need an accelerometer, MPU6050, one power supply, one breadboard, alligator clips, one set of connecting wires. For a brief introduction, articulated arm is a robot with rotary joints. It can be used for a wide variety of applications. In this experiment, the articulated arm is used as an output for the accelerometer sensor. So just like what I've said earlier, we are not to use an robotic arm, but instead we're going to use 3 servo motors, which will serve as our replacement for the robotic arm. This will also portray or reflect the output for the accelerometer sensor. So whatever the accelerometer sensor would read in degrees, the servo motor would reflect that specific angle. Moving on, an accelerometer is an electromechanical device that will measure acceleration forces. These forces may be static, like the constant force of gravity, or could be dynamic, caused by moving or vibrating of the accelerator. By measuring the amount of static acceleration due to gravity, you can find out the angle the device is tilted at with respect to the Earth. So there. The purpose of this experiment is to make the articulated arm mimic the movement of an actual arm by attaching the accelerometer on the model's arm. As the arm of the model moves, the articulated arm also moves following the angle of movement of the model's arm. This angle will be displayed on the GUI in Microsoft Visual Studio. So again, we're not going to make this. The angle is limited only from 0 up to 150 degrees. It is limited to 150 degrees because the angle is greater. Because an angle greater than this cannot be achieved fully by the arm of the model. This is to relate the motion of the accelerometer and the arm movement in real time. The program was created mainly in Arduino, mapping the values to achieve realistic mimicking of arm movement. The angle projection was shown on the interface created at Visual Studio simply to verify. So here, instead of Visual Studio, what we're going to use is just the serial monitor in our Arduino IDE application. So moving, let's go back to this part of our introduction. It says here that the arm moves as the arm of the model moves. So what I did, instead of placing the accelerometer on the arm of the model or the human, what I did was I placed the accelerometer in the breadboard, and then I held on to the breadboard, and it is the whole breadboard with the accelerometer in it that I moved upward, downward, forward and back, and left and right to achieve the expected results. So let's see procedure. So the setup, of course, we need to connect our computer and Arduino together using our USB serial cable. So here, this is for ADXL345 accelerometer. So what I used in my equipment and materials, I used MPU6050 instead of ADXL345 there. So I would not be following this schematic diagram or circuit diagram. What I will follow is this. So before we head on to that, let me just read the Arduino program that we're asked to do. So we're asked to create a program for the microcontroller that will control the angular displacement of the servo motor connected in the robotic arm by using an accelerometer. The accelerometer will be placed at the forearm. As the forearm moves, the X, Y, and Z value will be used to compute the angle for the arm. The angle created by the forearm will be imitated by the robotic arm. So again, this is how I connected the circuit. Just like what I said earlier, I connected it onto the breadboard, and this breadboard here, it is what I will carry or lift and move to see if the servo imitates what angle this accelerometer is at. So as you can see here, I've connected all the VCC together. The VCC for the Arduino 5 volts and the VCC for our servo. Next, for the ground, all of them of course should be connected. The ground of the accelerometer, Arduino, and the ground of the servos there. All here. Next, I also connected the SCL to the A5 of the Arduino, SDA to A4 of the Arduino, and this is for the PWM of the servo. It's connected to 7, 4, and 2. So it's connected to GPIO port 7, 4, and 2. There. And this is the schematic diagram and the interface code. There. So for our code, this is the code for the accelerometer MPU6050 laboratory activity or experiment number 6 in robotics laboratory. So for our main code, I included the library for the wire, the servo, and I've set servo 0, 1, 2 because there are 3 servos. This is for the X, for Y, X, Y, and this for Z. So next, const space int space MPU. This is for the library or the library of the accelerometer. Also, this code is for the accelerometer XYZ axis and their GY or their gyrometer. So int space the minimum value is 265 and the maximum is 402. So double XYZ there. Void setup, wire.begin transmission for the MPU or the accelerometer address. So this will write our accelerometer, and write 0, wire and transmission true. Serial.begin this will begin the servo and our accelerometer. So servo 0 is attached to GPIO 2, servo 1 is to 4, servo 2 is to GPIO 7. So for the loop, when there is signal or vibration or change in our accelerometer, our MPU6050, then this 0x3b will write, and wire and transmission it's set to false, and request form MPU address 14, true. So here this code will read what angle is in our X, Y, and Z axis. After that, it will compute or map according to what value it has, and it will project or show in our serial monitor here the angle of X, Y, and Z. Also, X, Y, and Z is equal to rad to degree. This will change the values from radian to degree. Then for us to be able to see what angle, or this will convert our data. for us to be able to see in our serial monitor. Next, it will print angle X. This is for the serial monitor, the printing itself, for us to view the code properly. And next, INT servo 0 value. This will map this code here, set of codes will be responsible for the mapping of the angle in our servo motors. So this is for the X, Y, and Z. It would have a delay of 400 milliseconds. So this will control the servos according to the MPU6050 orientation. So here, this will the servo here would react or reflect the accelerometer value that we would be getting and mapping in our previous codes. So there, this is for servo 0 for X, servo 1 for Y, servo 2 for Z. And of course, it would print that specific value that we got there. And all of those will have a delay of 500 milliseconds for interval for us to be able to see if it really moves or changes there. So now let's head on to my circuit, the circuit that I made, and let's see if this code or Arduino sketch works and if my accelerometer imitates the if my servo imitates the angle or the vibration and lifting of the accelerometer MPU6050. One more note, it can be observed here that the accelerometer is placed on top of the breadboard. In my circuit, what I did was it is at a 90-degree angle, so this one is lift up, not put down like that. This is because of the pin connections that I have here. So we'll see about that in the video. So here are the results for this experiment. So this is the MPU accelerometer 6050, MPU 6050. So let me upload the code. So compiling sketch. Note that this accelerometer is not soldered, so it could disconnect, and it requires me to upload again the code in our Arduino. So here in our serial monitor, we can observe a value of X is at 0 and Y is at around 50. X is at 90 rather, and Y is at 50, and Z is at 180. So first let's test Z. This is the servo for that. So when I lift this up, we can observe we should observe a value of 0 for our Z. So let's see. There, the servo moves, and the LR monitor, it becomes 0. One more, it becomes 180, and then 0 again, and then 180. For our y-axis, let's test the values. It has a default of around 50 degrees, so now let's change that. There, we can observe, the accelerometer disconnected, so let me just upload it again. Okay, there. Now let's test the x-axis. So here, there, 0, value is 180, servo moves, 0, 180, 0, and 180. And for our y, there, 31, 30, and it increases, and this servo moves to 50, 53, and 28. It lowers down again. There.